All right. Hello, everyone, and welcome to today's TVA EnergyRight webinar on enhancing industrial efficiency with demand management and load flexibility. This webinar is part of our ongoing energy management webinar series that's brought to you by TVA in partnership with local power companies to support industrial and commercial customers across the Tennessee Valley region. These events explore timely and interesting to you, hopefully, energy management topics from industry leaders and experts, and they really serve as a platform for discussion and information sharing with peers across a variety of industries. I did want to go over just a few logistics for the webinar today before we get started. We do have cameras and microphones turned off, but we are recording this session, so just want to make sure we don't have any mishaps there. I know I've been guilty of being off mute when I thought I wasn't before. We do have the Q&A function enabled though, so my colleague Ashley will be monitoring that throughout the webinar, and we'll try to answer questions as we go through the content, but we'll also have some time at the end of the presentation for those questions as well. So please share what's on your mind, put your questions in the chat, and we would love to hear those from you all. We also will have a poll in just a little while, so be on the lookout for that. You'll get a pop-up on your screen and be able to respond to that poll. Once again, use the chat if you have comments or if you have compliments. Wouldn't be mad about that. Just kidding. We will share this deck after the webinar, so you all will receive these materials for your reference as well. So before we dive right into the agenda and the objectives, I wanted to introduce myself really quickly and introduce my co-host. My name is Claire Moore. I work for TVA and I lead our demand response team. I was born and raised in the Tennessee Valley, so I've been around these parts my whole life and love this area. I have been at TVA for about 13 years in some various different roles. I started out in the nuclear organization on site. I've been in IT and I've been in some commercial organizations, but right now, like I said, I lead our demand response team, and I really love this role because I get to be a part of the partnerships that TVA has, and that's just something that's so important to us and is so rewarding for us. So I'm very excited to have Dr. Ethan Languri from the Tennessee Tech Industrial Training and Assessment Center with us here today to share his expertise. So Ethan, how about you introduce yourself, please?
Yeah, thanks, Claire. Hello, everyone. My name is Ethan Languri. I'm a professor at Tennessee Tech University in the Department of Mechanical Engineering. I'm also director for Industrial Training and Assessment Center. It's a program funded by Department of Energy. Maybe you have heard the name of IAC. So the training piece is a new term we added to the overall name. And I'm very excited to be here talking about load management, demand management, and have some first-hand case studies from our assessments that we've done for facilities, which we're going to talk more about today.
Thanks, Dr. Languri. Yeah. All right, so let's talk about what we'll cover today before we dive right in. This is an overview of our agenda today. We will be talking about really two approaches. So load flexibility, which is load shifting and load shedding, and Dr. Languri will share his insights and expertise with us around those topics. And then I'll talk a little bit about TVA's approach to demand response, opportunities for you to partner with us and talk through what that looks like. And then we will have some time for Q&A, as I mentioned. So that is a little bit about what you can expect. And before we dive into the main content, we just wanted to quickly overview a little bit about TVA's mission and then have Dr. Languri share about his organization as well. So hopefully, as many of you know, TVA has a 91-year history of serving the Valley to make life better. And that's really our core mission. And we do this with our 3 E's, we like to say, the pillars of our mission, and that's energy, environmental stewardship, and economic development. I heard someone recently categorize this from TVA, those 3 E's, as we like to say, we keep the lights glowing, the rivers flowing, and the valley growing by providing affordable, reliable power. So that's really what TVA is here to do, to serve the communities that are in our region. Within TVA, the organization that I am a part of is our EnergyRight team. And we really have a mission that directly aligns with that overall TVA mission. So our role is to unleash the Tennessee Valley's energy potential through demand management solutions and powerful partnerships. We really focus on system reliability and being a catalyst for economic prosperity and enhanced quality of life for the communities, business, and the households we serve. So you'll probably hear several times today a real emphasis from TVA on our partnerships with our local power companies, our customers, the communities we serve. Those are really critical to our success and having a thriving region for all of us and for our families. And then I will pass it over to Dr. Languri.
Yeah, at Tennessee Tech Industrial Training Assessment Center, the team is composed of a graduate student team. So you have a PhD student, master students, undergrad, and faculty and staff serving and helping the center. As you can see on the right bottom side picture, we have Tennessee Tech and University of Memphis as a satellite center for Tennessee Tech, covering most of the states, and we go beyond the state. And what we offer to manufacturing facilities is no cost energy assessment for manufacturing funded by Department of Energy, that we go deep into cost saving and energy saving opportunities plant can utilize. So a little bit more about ITAC or IEC, if you heard the name. So you see a map of IEC. So there are about 37 centers across the nation. So depending where you are watching this webinar, you may find a local IEC closer to your facility. Feel free to contact them. And the link is really shown on top of the map, iac.university. That's the name of the website that hosts all of those centers, webpage and portal. And you can request for a free, again, no cost energy savings. And we track our data. So this program has been around for over 45 years continuously. Tennessee Tech is established back in 2007. We have done over 330 energy assessments as of today, and you see the other stats in terms of number of recommendations we offered, how much energy saving we proposed, and cost saving implemented for the plant and students trained in our program.
All right. Thank you, Dr. Languri. Okay, we are now going to put out a quick poll for you all. We would love to hear from your perspective. So you should see a pop-up on your screen that will let you respond to this poll. And the question we would like to understand from you all is, what is the primary challenge that you're having when it comes to energy management for your facility? So for your business or your organization, we've put some options in there and would love to hear from you all kind of what your perspective is on the biggest challenges. All right, seeing some responses come in. Looks like a lot of folks are having challenges with high costs associated with energy. Yeah, we see that a lot. Also, some interest in data access. I know there's more data and more opportunities to leverage data now, it feels like, than ever. So that's definitely a very powerful tool. Sustainability, lots of interest in that as well, and then getting that C-suite buy-in. So thank you for that. That's really helpful for us to understand. And I will say, I think we will touch on aspects of all of these today. I think there will be a lot of information on cost saving opportunities and strategies related to that, partnerships with TVA with financial benefits for participants. So hopefully we will definitely be covering some things that will be of interest to you all in this space today. Okay, so before I pass it over to Dr. Languri, just again wanted to say, objectives for today, we are really going to highlight load flexibility and also demand response opportunities. Load flexibility, there will be strategies and solutions for optimizing your energy usage. And Dr. Languri has a lot of expertise in this space. He's going to share some really impactful examples and case studies with you all. And then I will talk about our demand response programs at TVA and opportunities to participate in those with us. So with that, I will pass it right over to you, Dr. Languri.
Thank you so much, Claire. It was a really good introduction about load flexibility. Now, really, it's time to go deep into load flexibility strategies you can implement in your plant, and we talk about some case studies that were successful to propose and implement in some of the facilities, again, in around Tennessee area. So I would like to start with this a slide that demand management or doing any energy efficiency project on your demand would not only save you costs, but really you target multiple load value proposition at the same time. So you make your system more resilient, you approach sustainability, you increase the life of your system because probably it's run cooler. You reduce the maintenance, and really today's focus, you're also helping TVA or the grid to have less stress really as a part of doing all of your demand management as well. Next. So really in terms of strategies for load management, today we're mostly focusing on load shifting and load shedding or load shaving really. Quickly, load shifting on the left-hand side, you see that we're talking about how we can shift the energy consumption out of on-peak high demand hours to off-peak, probably a second shift, for example. And we are mostly talking about, do we have an opportunity in your plan for working around the schedules or to make it happen? But in terms of load shedding would be, is the plant able to reduce some certain loads that we're going to talk about, ideally non-critical loads, as a part of during an on-peak demand part of a day, either if you participate in a demand response program that Claire going to talk later today, or in terms of really energy saving that I show in some examples. And shed some load, reduce your use during that certain hours in a typical day and back on, and how you can handle that load shedding, hopefully using some strategies, which we're going to talk later. Okay, I would like to start with interval power data, which is your roadmap to do the really demand management. We're talking about 15 or 60-minute kW power data of your plant. And a lot of time during our assessment, we request the last 12 months, last year of interval data of the plant. So that's the historic data. And a lot of newer plants, we see that they having their own on-site interval data and power collection. So they can generate their own interval data and record it or see it live. And we're going to talk about how looking at those interval data and basically working around with those numbers can give you idea of where you can do a load shifting or load shedding in your plant. So here I'm showing some plots that vertical axis is your demand, kW, power use of the plant. This is at the plant. And your horizontal axis is time. On the top left graph, you see that, of course, demand is everywhere. This is for 1 year of data. So you can see your max peaks, but you may not get a lot of information out of it. To the right, you can see that if you show an average per month and you show the min and max for each month, you probably gain more information out of this. So you see a monthly kW and max and mean, and you know in January you had a lower demand in general, and And also in other forms, you can be able to look at the historical data that you can request most of the time for free from your local utility. And sometimes you may want to record it on site. And you can gain some good valuable insight from those that, again, we use those in our energy assessments, try to identify opportunities where certain equipment may go either shifted or reduce the load to gain certain cost saving. And on top of that, there are incentives that, for example, in our region, TVA offers that you're going to add also to the other savings as well. So here we're showing an image from better plans of the DOE that basically capture the whole idea of in a typical plant, you have an office space, you have shop floor, you have some equipment, maybe a chiller tied to a cooling tower. You might have a boiler. A lot of plants has compressed air systems. So a typical plant which has all or combination of those that is tied to a meter and they receive their electricity from a utility. But think about it, if you can have access to some on-site power generation, maybe you have some PV panels or some other forms. You also have access to some building management system or a SCADA or an intelligence that can understand, hey, what's the weather looks like today? What is the schedule looks like today? How we're doing in terms of a storage in electrical battery or thermal battery if you have one, and can I utilize a demand response event in terms of cost saving? If yes, what loads I should drop. So this picture kind of shows an overall view of what we're talking today. Any plant, any manufacturing plant could use a version of those strategies as long as we collect the data and we have a plan to do this. So more on load shifting, basically using a buffer or energy storage system, such as can I shift this certain activity or process to a second shift? So it's more about a scheduling. Or can I store some ice and water overnight using some chillers, and I can use it the next day during the peak hours instead of running multiple chillers. So this way, I unload some chillers load as well while I'm pumping some cold water through the plant for my process cooling or space cooling. I have some examples such as using grinders on second shift. Believe it or not, it will show us major saving, and they can, of course, adds up. Or can I charge my electric forklifts during night shift rather than charge it on the shift one, or which is during happen to the peak time? Quickly on the right graph, I'm gonna quickly go over the solid line is your is your original demand that a typical plant uh, probably going to see. Of course, the plant by plant are different. And a dotted line, the green dotted line, is nothing what we expect. That can I go a little bit higher in terms of demand and run some process overnight when the electricity is cheaper and demand is less, and unload certain equipment like those chillers that we saw in one of our assessments in Huntsville, Alabama, then unloaded during the warmest and high demanding and really most expensive part of the day. So this way we can see some cost saving. Also on load shedding, we are talking about, can we have a demand controller or load shedder? It could be manual or really automated to reduce the load partially or fully of some equipment. For example, can I turn off or powering down some equipment, for example, an HVAC equipment for 2 hours while I pre-cool the plant, for example. Um, Or can I have access to a storage capacity, either thermal or electrical, that I can tap into? Or do I have access to on-site generation? I also mentioned a bullet on energy efficiency, that can we do certain energy efficiency that most of the process are now running more energy efficient, so the load during peak time is lower as well. And on the right graph, on the graph on the right, quickly, we're also showing that our original demand profile that start at midnight, peaks at around 1 p.m., 2 p.m., and goes down as shift one probably finishes. With load shedding, we're following that dotted line trend that maybe a part of a day we're going to unload some loads. This is a inside view of our ITAG database that I took this a screenshot for us to discuss a little bit. So what I'm showing is that ARC are assessment recommendation code, and there are some ARC codes related to demand management, which we see 3 or more of those on this slide. The one I'm showing a red line around it, is use demand controller or load shedder. And you can see that collectively all ISCs across the nation, we have done 576 recommendations on this. And recommended saving, you see the number, over $7 million. And implementation rate was around 37%, which means that out of 10 companies we recommended this, maybe 4 companies implemented this, and the payback is very low, a little bit over a year. I'm also want to highlight demand management. The ARC 2.31 is also very popular with the plans, and we see it a lot. So over 3,000 recommendations have been done with 40% implementation rate. The last one is also related to this, that again, using generator during peak demand periods, that again, with a payback of almost 2 years. So again, the concept is nothing new. There are over 3,000, 4,000 recommendation has been done in this idea of just load shedding, load shifting, and it's really getting popular again because make the plant very resilient beside the cost saving and other things. So what are the strategies if you decide to do a load shedding in your plant? So first of all, you should rank your loads. So you have to have a strategies if you would like to start following a load shedding. Again, either you are participated in demand response program of TVA, or sometimes just for cost saving, that I have some examples. You can rank your equipment to non-critical, critical, and deferrable. So critical equipments are equipment that you do not want to turn them off. So they have to run constantly because they're related to your basically bottom line. Non-critical could be, can I turn off my HVAC for 2 hours? Maybe can I turn off my nitrogen generator, which I have on site to create and store nitrogen in the plant for a few hours, which doesn't interrupt with my process, with my production really. Deferrable could be some activities that I can push it to afternoon or second shift. And of course, critical is that we don't want to turn them off. How you can do this? It could be manual. So you can really, a maintenance person can go and turn them off a certain equipment for a period and turn them on back. Or it could be based on using sensors and some rules. So you need to have some instrumentations in terms of power measurement, in terms of pressure, temperature, flow, depends on the process. And you decide when is the time and let the sensor do it for you, or it could be forecasted way more automated. So what are some tactics in terms of load shedding that we saw in our assessments? Some facilities, they do pre-cooling or preheating. What do I mean here? We've seen a facility that pre-cooling the refrigerator when they store their products, and now the temperature set point is below what it should be. When we get to the peak hours, when energy is more expensive and you have to pay for more expensive demand, they could turn off the compressors of the fridge, and basically you get a free cooling because you did the pre-cooling during the off-peak hours, and that's how you navigate through those high peak and more expensive demand period. Um, you can have a staggered start. If you have certain equipment, can you uh, turn them on one at a time rather than all together, which we can get into discussion of setting a new peak and having to pay a penalty for that as well. Do you have a storage capacity, either electrical or thermal, like ice storage we talked about, or electrical storage, a battery set, if you tie that probably to your PV panels? Do you have access to some on-site power generators, such as a CHP that could work in combined with your boiler, or it could be a diesel generator, or really in general, CHPs are equipment that you can generate some electricity on site and using the waste heat for other applications such as steam generation or hot water generation. And of course, other renewable or on-site technologies such as solar or other technologies. So more on load shedding. Now you can use some hardware and software again to better predict when this could happen, how this could happen. In terms of hardware, we talked about the smart meters that you would like to tie to your software that kind of tap into what resources I have available now, what incentives are out there, if unloading certain equipment makes sense financially or not. Again, some instrumentation such as current transducer CTs that you could put on each line and make sure you understand what's the power use of the plant or each line inside the plant. And of course, disconnect relays. In terms of software, there are various software out there for purposing the really management system of the demand or particularly load shedding, such as EMS, energy management systems, or a SCADA that is nothing but really some intelligence, a brain inside your system that you receive all the real-time data from all your process and equipment, and you can control them as well. Or you could use some forecasting tools that it allows you based on the production and the scheduling and ambient weather and information about the storage, what's the best and when is a good time to unload. Now let's talk about some case studies that we have done in our center, and we wanted to share with you on this particular example, in this particular topic. So in one of the assessments we did, they were using ball mills, and ball mills are really large mill, exactly what you see in the graph. And inside there are ceramic or steel heavy balls that they are trying to crunch the material inside and make them a powder or a slurry, depending on applications. So a large electric motor at a very low speed run those big drums. In this particular assessment, we were able to work with the plant people to identify 2 out of the 6 ball mills that could be shifted during the off-peak hours. So second shift could run this. They were not essential to be run on the first shift or during the peak hours. So by doing this, we identified 900 kW could be shifted to off-peak hours for 20 hours per month. Of course, we helped them to identify, hey, for each season, depending on the radius structure, where those hours could be. And this is again, done with collaboration with the plant people, so it was not interrupting with their kind of scheduling as well. On the next slide, we see the savings that you could see just by doing this recommendation. So really recommendation was reschedule the operation of those two bulb mills to off-peak hours. Uh, Rates, look at here, the plants are using two different rates. I guess this is really tied to the this topic as well. So for during the on-peak hour, the energy cost was around 6 cents per kilowatt hour. But during the off-peak hours, just I want to highlight how cheap the energy cost is. So 0.0005 dollar per kilowatt. So almost 100 times less expensive than on-peak energy. And of course, there's the demand cost, $6.6 per kilowatt hour as well. You see some calculation here that shows that total cost saving on the energy and demand combined would be $84,000 for the plant just by having their team to operate these two bulb mills on the second shift. Another example that we've done in another assessment, again, this was developed with the collaboration with the local utility experts. So it was really fun to work with them. So here you see a grinder machine that they use it to grind a scrap material. It could be plastic, in some cases it could be metal pieces. But this 62.5 kW motor, and I was surprised because it was not exactly 60 or 70, it was 62 and a half based on the name tag. You have a conveyor and they kind of load the conveyor and the part goes inside the grinders, and that's how they probably recycle some of the material. But in this particular case, the grinder is on, and operators basically, when there is a part, a scrap part ready, they bring it here and they grind it. In the next slide, we show that how we could navigate from the existing scenario that anyone can use grinded at any time to a more scheduled one that can we have the grinder off on the first shift, which you had during the peak hours, and do it on the second shift, or gather them and do it over the weekend, which is still your, again, off-peak hours. By doing this, really, plant was able to save $10,000 just on cost, on demand cost saving. And of course, by not running continuously, you have a major energy cost saving, which is not shown here. So the rate of the demand was around $40 per kW. So by doing this, you're you're shifting this load to a second shift, and you're just using a less expensive demand. So really, today we talked about benefits of load management is not only is cost saving, which we showed is you can apply those on multiple and receive major cost saving, but also you can tap into incentives that Claire is going to talk about later today that TVA offers, equipment protection rather than you're unloading your equipment. You unloading them, you kind of run them cooler, longer life, and less maintenance costs. And this is my last slide before I turn it to Claire, I believe. And quickly, I would like to highlight that there is a federal grant called ITAC Implementation Grant that DOE offers to any manufacturing facilities that that they can use up to $300,000 federal grant as a part of a cost share for the energy project. So you can apply to this grant if you received an IAC or ITAC energy assessment done for your facility. So if one of your projects or multiple of your projects make our recommendation list in our report to you, then you can apply to this grant by really following this QR code. For example, for a $60,000, $100,000 project, you can tap into 300K from federal grant, and remaining you pay out of plans. And this is how you implement your project. This program I would like to highlight has been started maybe a year or 2 years ago, and it still is out there available for you to use. And this is exactly directly funding going to the manufacturing facility, and has been supported by our government very well as well. Claire, I believe this is my last slide. If that's correct, I'll give it back to you.
Okay, great. Thank you so much, Dr. Languri. I wanted to just take a few more minutes to talk about TVA's approach to demand response with you all today. And I like to start with a story that I think really illustrates the importance and the impact of demand response. So a lot of you may know that in late January, TVA met the all-time system peak request for demand in our entire 91-year history. So really a monumental day, a big milestone on that day. We had a new record peak of over 35,000 megawatts. We had some cold weather coming through and a lot of things going on in the system. So really was looking to be a very challenging day for TVA. And the role that demand response played in that instance was that our demand response partners contributed over 1,300 megawatts of load reduction to the system. Just to put that in context, that is about the size of one of our nuclear units. So a really, really significant contribution that helped TVA meet the peak that day. And again, that is thanks to the partners that we work with that participate in these demand response programs. From a cost perspective, using demand response allows TVA to avoid purchasing power on the market, especially during peak times when that power is very expensive, and helps us really keep that money in the valley with our customers and our communities, which is something that aligns with our mission and that we want to do. So a lot of end use demand response participants, over 1,300 partners that we have in these programs with TVA, who really banded together and helped us have that huge impact on the system. And we also have some demand response that is for emergency only situations. On this day, we did not enter into a system emergency, so we still maintain several hundred megawatts in reserve in our emergency demand response portfolio that we did not have to call. So really a huge achievement on that day. So hopefully that illustrates to you how valuable demand response is. It's a very powerful tool. So just in a nutshell, demand response is a series of programs. We have a portfolio of demand response programs at TVA where we partner with companies and local power companies so that they reduce their electricity consumption when TVA calls upon them and asks them to do so. So that's really what demand response is. On days that we make those calls and we request curtailment, we refer to those as event days. So if you hear me say the term event, that's what I'm referring to, a demand response event when we have requested that curtailment. But there are a lot of benefits across the board for people participating in demand response and for TVA and for our communities as well. We like to categorize it as win-win. So TVA benefits, it helps us maintain our reliable system, that continuity that we are known for in this region, and that makes this region really attractive for a lot of prospects for economic development, for low cost power. It helps us keep our fuel cost adjustment low. So that's a component that goes into our billing for customers. So that's very important. Demand response provides a benefit for that as well. And we also hear a lot from our customers who participate that they like being a part of the solution, being a part of engaging at that regional level and being able to help across the board. So demand response, we love it. We want more. We've been very busy. We are growing our demand response portfolio, and TVA is investing in demand response because it is such a powerful tool for the system, and we have seen great success with demand response. Just in the last couple of years, we have launched 4 new demand response programs or redesigns of existing programs to make those more flexible and get more people to partner with us in that space. And one of the big benefits of that is we have increased our capacity hours by over 4 times what we had just a few years ago. So when I say capacity hours, the portfolio consists of megawatts. That's how much demand. The capacity hours is how much we can use those megawatts. So over 4 times the ability to utilize those megawatts in our demand response portfolio than what we had just a few years ago. And that's very, very significant and very helpful for our system. We see an average event performance of over 100%, and that means when we call on our participants, they often give more than what they are contracted to give. So they're able to get below their protected demand, which I'll touch on in just a moment, but very strong performance in this space. And that's really critical. Our operators, they like demand response. They know that they can depend on demand response when it's needed for the system. And our partners get benefits from that as well in the form of incentives they receive. This is just to give you all a bird's eye view of the demand response portfolio. So you see we have several different programs, and really what we want to do in this space is to have something for all of the market segments that we can, so that we can partner with as many people as possible to benefit in this space. Today I'm going to go into just a little more detail on our PowerFlex program and our Peak Rewards program. That is what is going to be most applicable for industrial customers. So we'll talk about those just a little bit more, but I also wanted to show the full picture of the other programs that TVA has as well. So we have a smart thermostat program that we have just launched a few months ago, and that is for residential customers of our local power companies can sign up. They can maintain full control of their thermostats, but receive incentives to partner in the demand response space. We have a program for new loads coming to the Tennessee Valley. We've seen a lot of growth, so it was really important that we had a demand response option for those folks to be able to partner with us as well. And then we directly collaborate with our local power companies for our voltage program, which is also a really great tool for our system. All right, so a little bit about PowerFlex. We launched PowerFlex almost a year ago. This time last year, I think it was about June that we opened this program up for enrollment, and it is really sort of our flagship. Some of you may be familiar with interruptible power, or IP5 and IP30. PowerFlex was a redesign of our IP program to really try to offer more flexibility and more options to more participants, and also to increase those capacity hours I just talked about, how much utilization TVA has of the megawatts that are in this space. So we launched this program a year ago. It's been very successful. We have over 900 megawatts enrolled in the program, which is really tremendous. Some of the requirements to participate in this program. So this is typically, we see larger industrial customers that partner with TVA in this space. The requirement is just that your contract demand is greater than 1 megawatt. And as far as how much interruptible you could provide, that is 500 kW average on peak per month, and that's on a rolling annual basis. So it could be a little more some months, a little less some months, but that average is the 500 kW per month rolling. You are able to set a protected demand. So Dr. Languri talked a little bit about identifying critical processes, maybe deferrable processes. That's something that is important in this space, because when we have a conversation with a potential participant about this, we're going to ask, what would your protected load need to be? And so you have the ability to say, hey, my total load is 5 megawatts. I need to maintain at least 1 megawatt of demand at all times. So we would want you to set your protected at that level that makes sure you have appropriate continuity of critical operations, even during a demand response event. This program does have emergency only, which means we would only call upon those participants if we got into a system emergency situation, like Winter Storm Elliott was the most recent one a few years ago. Those are very rare, but we do have that option to participate in this space. And then we have emergency plus capacity, and that's where you can elect how many hours per year of capacity calls you would like to sign up in. The way that the credits are structured for this program is that you will receive a monthly capacity credit based on your interruptible load. And that rate varies depending on how many hours you sign up for and how long the notice period is. So I will show some of those features in just a moment, but that sort of helps determine what that credit amount looks like for participating. Right now, contracts are available. Those go through September of 2029, and the pricing that's in place right now is applicable through September. On an annual basis, we take a look at the pricing and make sure that it still is in alignment with system needs and the value that we see in this space. But current pricing is set through September. And of course, at the time you enroll in this program, whatever the pricing is at that time, that's maintained for the lifetime of your contract. So that would not change once you've enrolled. Just as an example, some of the types of industries that we commonly see participating in this space, chemical manufacturing, automotive manufacturing, data processing, metal, paper. We have a pretty good variety. Those are just some examples. That's not all inclusive, but to give you an idea of the types of partners that we have in this program. So I mentioned the flexibility. That was really the genesis of redesigning this program for PowerFlex and trying to have a menu of options to try to meet people's operational needs. We know different industries have very different needs. Some have shift work, some have processes that they need longer time to know if they needed to curtail. And so we really tried to expand the options in this space to meet people where they were and give them the opportunity to participate in this space. You see for notice period, so that's how much time you would have from when TVA notifies you of the request to curtail until you need to actually be at or below that protected demand that you've set. So for a capacity call, that could range from 30 minutes up to 12 hours in that space. And then for an emergency event, that could be anywhere from 5 minutes up to an hour's notice. Previously, there was only a 30-minute notice for capacity and then a 5-minute notice for the emergency only. So really have tried to expand those options for the notice period. And then you see the capacity hour options that I mentioned. So starting at 24 hours of capacity, going all the way up to 96 hours or more. We have those on there, so you can sort of pick how many hours per year would make sense for your operations on that annual basis. And again, we do have that emergency only option in this program as well. Okay, and then I like to just show an example. So if you're sort of starting to think about this and you're thinking, well, probably our industry, we could provide 500 kW. Maybe we could provide a megawatt of interruptible. So what does that look like when we start talking about the credits you could expect? So this is just an illustrative example. If you're able to provide 500 kW average interruptible and you were to sign up on the top row there with the light blue for 24 hours a year of capacity calls, then you can see the associated credits that you would receive on an annual basis for that level of enrollment. Those energy credits are paid when we have actual demand response events. So when we do actually call and ask you to curtail, you receive that energy credit. That's $100 a megawatt hour. The capacity credit is paid on a monthly basis, whether we have a demand response event or not. So I like to think of that as you are getting a credit to be on standby. Whether we need you or not, you're on standby and you will receive that credit. Conversely, if you're able to do more capacity hours on the bottom and you can do 96 hours, you can see again the associated credits that would be for that 96-hour election.
Hey, Claire, we have a question in the chat that might be pertinent at this time. How is the peak kilowatt determined? Is it the highest point in the last 12 months?
Sure. So for PowerFlex, we set a baseline, and that baseline is done in a period of a few hours prior to the actual event call. So one of the requirements for PowerFlex is around metering. We do have to have 5-minute meter interval data for PowerFlex participation, and that allows us to really make sure that we are reading that data, capturing that baseline, and giving the credit for the actual amount that is curtailed in an event. Thank you for asking that. All right, I'm going to go through these a little more quickly, and since I've sort of laid the foundation here for what these numbers mean, this is just an example. If you can do 1 megawatt of interruptible, again, those associated annual credits, looking at over $60,000 a year for a 24-hour election, and going all the way up to over $120,000 a year in that 96-hour election. And of course, there are hour blocks between, and those ranges would vary as you would expect. And then lastly, let's say you can give 5 megawatts interruptible. The credits are really substantial. So the more interruptible you can give and the more hours that you choose to enroll in, the higher you're going to see those credits continue to go up in this program. Okay. And then I wanted to touch quickly also on our peak rewards program. So maybe you were listening to PowerFlex and you were thinking to yourself, I'm not sure if I could qualify for that. Maybe I don't know that I have enough interruptible demand to do PowerFlex. I'm not sure if that's for me. So we also have our peak rewards program, and this is really an opportunity to partner for maybe smaller industrial or commercial businesses. That minimum interruptible requirement is substantially less for this program than it is in PowerFlex. This is a nominated program. So in PowerFlex, you set a protected, and when TVA calls you, you need to get down to at least that protected or below. In Peak Rewards, you're able to nominate on a monthly basis. Hey, if I was called this month, I think I could give 70 kW. So the requirement for Peak Rewards is a 50 kW reduction, and that is going to be a seasonal payment that you would receive for participation in this program. Some details around this, the frequency. So there's up to 32 hours of economic calls per year. TVA's peak is typically 4 hours. We do have the ability to have a call in this program last between 1 and 4 hours, but most often we have 4-hour calls, typically is what we're going to see. And then there are some limitations in this program around when you can be called. So it is going to be during the week, no holidays, no weekends, and there are set hours with that 30-minute notice. And you can see here a variety of the types of participants in this space. We have schools, we have retail, we have small businesses, churches. So really, this is a great space for smaller power users to combine, but to have a really big impact on the system.
Hey, Claire, we have one more question in the chat that I think you might want to answer now. If a company has multiple meters, are they combined in this program?
So for NL, actually I just said NL and maybe no one knows what that means. I was going to introduce that here, so that's good timing. So TVA partners with an aggregator for this program, and that is NL. Some of you may have heard of them in the past as Internoc or NLX, but they are our partner and they provide services as an aggregator. Part of the service that they provide is they handle the metering. So NL will make sure that appropriate metering is installed, and then they will monitor that. They will help participants figure out a load reduction plan and identify opportunities to reduce load and what they could nominate in this program. So that is something that they will help with. I know typically when TVA is doing direct metering, we can combine meter data. If a customer has multiple meters, it's more based on the customer number for TVA. So I'm pretty sure that NL can probably do the same thing. But if you have a specific scenario, we'd be happy to follow up and discuss that in more detail. All right, so I mentioned NL provides the metering. That's a benefit in this program. There are no upfront costs. You don't have to take on getting a meter, installation, anything along those lines. NL, as our partner, handles that for you. We do an acceptance test prior to enrollment, and that is really for your benefit to make sure that you can actually execute on your load reduction plan. Everyone knows what needs to be done to meet that nominated demand reduction. I mentioned the 32 hours. That equates to about 8 to 12 calls per year is what we expect and what we typically see in this program. And there are maximums. So no more than one event per day, 6 events in a month. We're not going to be calling you, back to back for 8 days in a single month or anything like that. And then along the payment structure for this one, I mentioned it's a seasonal payment similar to PowerFlex. There's a capacity payment that's kind of like being on standby that you would receive. That's $2.50 per kW month. And then for energy, so for actual events, when you are called and asked to curtail, then there is an energy payment that is made at that time as well. Just quickly wanted to show this as an example. So for both of these programs, you will receive access to data and be able to see your load. This is a screenshot from the platform that NL provides access to when you're in the Peak Rewards program. So you can see your real-time load, which I think is really valuable. And that can help you with some of the strategies that Dr. Languri talked about. So not just in a demand response event, but having access to that real-time data to identify trends and opportunities. We also have something similar to this for our PowerFlex participants. It's called Valley Connect, and that is a TVA hosted platform that those participants receive access to as well. All right, this is a quick summary of sort of what I've covered, details around PowerFlex versus Peak Rewards. If you're thinking about maybe which one would be a good opportunity for you, just wanted to include the side-by-side comparison here. I'm not going to read through this. I think I've talked to most of it, but this will be in the materials that'll be shared with you all after this webinar. Okay, and then lastly, I mentioned about notice period, 30 minutes, 1 hour, 12 hours. We do try to make sure that we are being very transparent with our demand response partners. Every week, TVA sends out a probability of curtailment, or a POC. That's an email that goes out. It's this bottom left image. Red, green, yellow. Green means we don't think we're probably going to need to call anyone. Yellow means we might. We're keeping an eye on things. Red means you probably could expect that there's a likelihood that there's going to be a call. And we send this out every Monday. We update it. If anything changes, we'll send it more frequently. NL also sends out an email similarly to their participants that are in our program, just to let you know. So we really try to give as much notice as possible, even beyond those contractual notice periods, just because I think it's better for everyone. And that's something we try to make sure we do. So lastly, I've included a list of questions here, just things that can be helpful if you're considering what a good fit for you might be. This will be in your materials as well. But these are some of the things that we typically have conversations with folks about for demand response. So if you're interested, these are your TVA EnergyRight representatives. We've got a slew of great folks that are out in the field and that are very, very well versed in these programs and can help you if you have questions, can help you connect with our team. So wanted to include that contact information for you all today to take with you. All right, I know we are getting very close on time, but we've got just a couple of minutes here that we could open up for questions.
And again, if you want to put your questions using the Q&A function, you should see that at the top of your screen, or you can just put them in the chat. Either way, happy to grab them. All right, we've got a question. I think it's aimed at you, Dr. Languri. It says, thank you for your great discussion today. Could you elaborate on how facilities with continuous processes or operations can still benefit from demand or load flexibility management strategies when maybe the full shutdown isn't possible?
Sure, that's a very good question. I know we only have 2 minutes, so I'm gonna give it you a short version. Even for 24/7 operation, such as hospitals, of course, they're not industrial users, but manufacturing that run continuously 3 shifts, you can still identify some non-critical loads that participate. Again, my example of HVAC, or nitrogen generation, or or processes that are not related directly to the production. You can still identify those. Can you stagger turning on certain equipment rather than running them at the same time? And another option would be, do you think you can tap into on-site power generation, or a diesel generator, or any other form that you can still try to unload certain load during an event? Those are available to you, but again, those would be a good discussion you should have with your energy team or with experts in the field.
Got another one, and I think this one's probably aimed at you, Claire. For companies considering power flex, what data or metrics should they be tracking now to help determine their optimal interruptible capacity?
Yeah, sure. So determining the critical processes that would be a need for their protected demand, their ability, how much flexibility they would have, that's really going to be the first step. The associated demand, for those processes, so that we can identify what that protected demand needs to be and make sure that we're setting that at a level that's going to be achievable. I think that's really going to be the first step and the most important thing.
Great, and I'm not sure which one of you might want to answer this one, but we also have a question in the chat. Can you just talk a little bit about smart devices is the question. So maybe that's how smart devices might be able to support these strategies.
I can quickly talk on this on my side. Smart devices are devices that, of course, you can, for meters, you can, of course, meter how much energy you're using from the grid, like traditional meters, as well as If there are other sources of energy tied to the same meter coming in, they can also include those in their calculation. And next level would be if you have a SCADA in your plant that all the process and equipment are instrumented and sensors are collected real time. Now you can make some machine learning processes, or you can do some forecasting that now you all of those are could be called a smart meter, that you make best decision as a plant manager or energy manager for your company to make some certain decisions in really context of this talk, when to unload some loads, or what's the best scenario in terms of cost saving or other benefits.
And I know we're over by 1 minute. I think Dr. Languri and Claire are okay to stay another couple minutes if anybody has any other questions. We also have here on the screen some QR codes that can lead you to some specific resources to help you. So please take advantage. But of course, we'll also send out the deck to all attendees. So if you don't get a chance to screenshot or something, we'll send these. Any other questions folks have for our experts here? Right. If you do have questions afterwards, you can always send us a message, an email. Dr. Languri, Claire, would you mind putting your email addresses in the chat? And that way, if they want to grab those, they want to send you an email with any questions, please do so. And yeah, we just want to thank you all. And Claire, I don't know if you had any final words you wanted to offer to our attendees.
Yeah, thank you all so much for your attendance, and thank you, Dr. Languri, for sharing your expertise and your insights. Really appreciate you being with us today, and we hope you all enjoyed this. Hopefully that was helpful. You got some good takeaways, and hopefully you will take advantage of future opportunities. I think we'll have some more of these coming out, and so keep an eye out for that. And like Ashley mentioned, there's QR codes, so take advantage of those to lead you to some more helpful resources. Thank you so much for being here. Hope everyone has a great day.
Have a good day.